holes in vertical asymptotes, okay, of rational functions in particular. So on a graph, we can potentially have vertical asymptotes, and we could also potentially have holes. So for example, I have a little picture here. Here's a rational function graph. We have this vertical asymptote, and we also have a hole at this spot. So notice that this was the original rational, although you could multiply this out and make it look like an actual polynomial over a polynomial. But notice that we have a hole at 1, 0.25, okay? And we also have a vertical asymptote at -3. So now just seeing this example, let's talk about how we actually find them. A hole. A hole is a removable discontinuity. You might see that phrase later on. Place where the function does not exist in a function. A hole in a rational function is found where both the numerator and the denominator equal 0. Okay, so you'll find your x value for that hole, and we'll talk about how to find that y value shortly. Vertical asymptote is a non-removable discontinuity in a function. A vertical asymptote is found where the denominator is equal to 0, but the numerator is not. Okay, so let's do that for a couple of these. And let's start by looking at f of x. What I'd like you to do right now is go ahead and pause me, and I'd like you to factor really all of these, okay? I'd like you to factor f of x, h of x, g of x, and m of x. So put me on pause, factor them all. All right, so you can see how I factored f of x and h of x here. So the directions ask us to identify the domain, the holes, and vertical asymptote, okay? So first of all, let's start with our domain. Domain, remember, is going to be everything except for which x values make this undefined. So we know 5 and -3 should be taken out of our domain. So that's going to be -infinity to -3, union, -3 to 5, union, 5 to infinity. Okay, so we found the domain. Next thing that we're looking for is the hole. Okay, so if I'm looking at the hole, look at your two factors that are going to cancel out. Remember, we talked about that removable discontinuity where it doesn't exist, there's a 0 in both the numerator and denominator. So the hole has an x value at -3. We want to figure out the y value at that spot. So to do that, we're going to plug in -3 into x for what's remaining. So I get -3 plus 2, which is -1, over -3 minus 5, which is -2. Sorry, -3 minus 5, which is -8. So we get 1e. Last but not least, we're asked to find the vertical asymptote, which is where the denominator equals to 0, but not if there was a hole. So we would only worry about at this 5. And that's, since it's vertical, it's going to be x equals 5. Okay. We'll do one more with you guys, and then we'll have you try the next two on your own. So domain here, everything except for -2. Let's see if we have any holes. Do we have any factors that cancel out? And we do. So that's going to be at -2, comma. Now to find our y value, we plug in our x value into what's remaining of my function. I get -2 minus 2, which is -4. Vertical asymptote. Well, the only thing in my denominator has already canceled out as part of my whole, so we don't have any here. Oops. Okay, so now what I'd like you guys to do is for g of x and m of x is to do the same exact thing, and then we'll check your answers. Go ahead and put me on pause. Okay, let's see how you did. So for g of x, I started by finding the domain, which I found that 3 and 5 would not be part of my domain. So here you go. Next, whole, I don't have any factors that cancel out here, so I don't have any wholes. And then last but not least, my vertical asymptote, I do have 2 of them this time. It is possible to have multiple. So x equals 5 and at x equals 3. At m of x, my domain, so the only number that can't be part of my domain is 0. Okay, you might be wondering, well, what about this x squared plus 1? If you set that equal to 0, you get plus or minus I, which aren't real numbers, so just 0. Whole, now the x's would cancel, so 0, comma, negative 1. Remember how we get that negative 1. And then vertical asymptotes, none. Last thing I'd like you to do on your own is I'd like you to, in words, describe the following things. How do you find the x value of the whole? How do you find the y value of a whole? If you don't remember, maybe go back to a couple of the earlier examples where I was explaining that. And then last but not least in words, how do you find a vertical asymptote? So 3 really important things to take away from this video.